All right, we're going to take a look at our DMR from yesterday to get our math brains warmed up. Look at the graph below. How many kids surveyed prefer science? How many prefer science? Science is right here. Our key is right here. 1 pencil equals 2 students. 1, 2. I have 2 pencils. That's 1, 2, 3, 4. And then I have half of a pencil. Half of 2 is equal to 1. There are 2 parts right there. So this is 2 plus 2 plus 1. That is equal to 5 students. Several of you chose 2.5. I don't know about you, but thinking about half of a student makes me a little nervous. I don't know why a student would be cut in half, but I don't want to know. So let's choose things that make sense, right? 2.5 students can't like that because let's be honest, if you're cut in half, you're dead. So 2.5 would be an incorrect answer, okay? So we've got 5 students because 1 pencil equals 2. So 2, 4, and half of 2 is 1. Questions on that? A lot of y'all are creepy. You're smiling at the idea of half a student, and that's worrying me. You're worrying me a little bit. That should not make you smile. That should make you cry and scream and run away and say, "Mommy." All right, let's take a look at the next one. Use our comparison symbols to compare 3/3 and 2/3. These have the same denominator. When fractions have the same denominator, we are going to look at which is the greater numerator. 3/3 is greater than 2/3 because 3/3 is a whole and 2/3 is missing a piece. All right, let's take a look at number 4. It says choose all. In this case, all equals 3. Look at the fraction below. Choose all that is true about this fraction. This fraction is 4/5. 1 more unit fraction would make this equal to 1 whole is true. If I added 1 more fifth, I would have all 5/5, and we know when we have all of our parts, that is equal to 1 whole. There are 5 pieces in this whole. That is also true. Our denominator is a 5. Denominators tell the size of the whole. This is more than 1/2. That is also true. Half of 5 is 2.5. 2.5 plus 2.5 is equal to 5.0, which is equal to 5. So it is more because this is more than 2.5. There are 4 pieces in this whole. This is a unit fraction. Questions? I'm still disturbed by y'all talking about some half of students and laughing at it. I don't know what's going on with your brains, but you need to fix it. All right, here we go. How much is this in dollars and cents? Don't forget to put your dollar and decimal point. We did better today. Some of y'all still forgot that decimal, so you got it wrong. Make sure on your quiz tomorrow you put that decimal. This is a $5 bill. $1 is $6 plus another dollar is $7. A penny is worth 1 cent. So we put a 0 where the dimes go and a 1 where the pennies go. Some of y'all yesterday wrote 7.1. That would be $7.10. Nope. 7.01. Penny is in the ones place or the cent place, okay? All right. Final one, there are buckets. Those buckets remind us that we can count by larger numbers than 1. If the dividend is divided evenly by the divisor, what is the quotient? This is 80 divided by 5. I know that I'll be able to fit 10s in there because 5 tens would be 50, and we need to get to 18, okay? Or 80, sorry. So I'm going to put 10, 20, 30, 40, 50. So I've just gotten rid of 50. That means I've still got 30 left. Well, counting to 30 by 5s is very easy. 5, 10, 15, 20, 25, 30, 6 times. So we're going to add 6 more in each bucket. So each bucket has 10 plus 6. 10 plus 6 is equal to 16. So your answer is 16. 1, 6 with the 1, 1, 6. What y'all know about the 1, 1, 6? All right, here we go. There it is, 16. Okay. All right, gremlins, here we go. Math time. Oh, here's the math, it never fails. It makes me wanna use my mouse. When it comes, I wanna wail. Math. Don't look at me like that, thank you. You know that's your jam. All right, here we go. What makes a good scale? That's what we're gonna take a look at today. We have been working on reading graphs. Now we're gonna look at making graphs, okay? Creating those graphs. So if you would please click on that add response. As you are opening up your response, I am going to play our success criteria so that you know our goal for today. Here is our goal.
Today we'll be continuing with creating scaled picture graphs, scaled bar graphs, and frequency tables to represent a data set. Yesterday we started creating our graphs using a frequency table to represent our data. Today we're going to be really looking at that scale and making sure that we have a scale for our bar graphs, picture graphs, and line plots that makes sense. So again, our guiding question today is going to be, does our scale make sense?
All right, so looking at does our scale make sense? That is our goal for today. Here is an example of what a scale of, I apologize, not what a scale is, you guys know that, of why we need to have scales that make sense, okay, with the data that we are given. Here we are.
Today we are going to be using a frequency tally chart to complete a scaled bar graph, pictograph, and line plot. I'm going to start today with our bar graph, and we're going to focus today on determining what is the best scale to count by for my bar graph to make it easier to interpret the data, answer questions, and analyze the results. We're looking at Steve's class. They voted for their favorite snack. Steve made a tally chart of the results. We've got popcorn, fruit pops, and yogurt. The first thing I'm going to do here is I'm going to count up each category and write the total. We've got tally marks here, so this is a group of 5, 6. For fruit pops, we've got 5, 6, 7, 8. And for fruits yogurt, we've got 5. So here I can see that I've got 2 even numbers and an odd number. We've got groups of 5 here. So, I might think, oh, let's count by 5s for my scale. And that might make a really quick graph. So I'm going to come here and remember, we've got our categories across the bottom, popcorn, fruit pops, and yogurt. We've got our title. We've got the place for our scale and numbers on the side. And right here, I said I'm going to do a scale of 5. As I make my chart, my bottom number, the one right here, is always going to be a 0. Remember, our graphs always start at 0. And I'm going to count by my scale, which is 5. So I've got 0, 5, 10, 15, 20, 25. So for popcorn, my total was 6. So I am going to color in that much. So I will color for popcorn. Let's make it kind of match that blue. So I'm going to start at 0. I'm going to go up to 5. And then 6 is one more than that. Well, I don't want to go up to 10. Halfway between 5, because see, there's another line here. So halfway between 5, 5, 6, 7, 8, 9. Well, that doesn't make as much sense. I'm really struggling with that. If I put it just like a little bit above here, which I think it might be, I hope whoever reads this graph will be able to figure it out. Let's keep going and see if the rest is easier. Fruit Pops had 8, so I can go, it's not up to, all the way up to 10, but it's up to 5. 5, 6, 7, 8, 9, 10. So somewhere in here, I know that 8 is closer to 10 than it is to 5. So I'm going to go a little bit over halfway. Oh, I hope my person can read this chart.
Okay, so Miss Sharp is being funny here by saying, I hope that she can figure it out and read it. This is not a good scale. Look how much of the graph is not being used. All of this up here isn't even being used. That's a waste. And I don't know if she's calling this right here, is it 6? Is it 7? Did she make a mistake? Is it 8? So this is not a good scale. So she's going to continue to explain why this is not a good scale.
And now for yogurt. Well, that's going to be an easy one. That one works out nicely because it's 5. So my reader will be able to understand this chart because it stops right at the line. But I'm not sure they'd be able to answer how many more and how many less because this chart is not very clear. If we covered up this graph, this frequency chart over here, and my reader could not see what the answers were, they might struggle here to find out and figure out how many people chose popcorn and how many people chose Fruit Pops. So it might be hard for them to answer how many more people chose Fruit Pops than popcorn. I might need to come up with a different scale. Look at the next slide and watch a different example.
All right, first of all, I'd like to say, Steve, I'm a little bit offended that you didn't ask me about my favorite snack. So if next time you could include me in your survey, Steve, that would make me feel a lot better. Okay? All right. Is that okay, Steve? Is that okay? You'll get me a snack next time? Okay, thanks, man. Thanks. All right, so that is not a good scale. This is an example of a better scale or a scale that's going to make sense to the reader.
After watching the previous slide, you can see that my scale that I first chose was not the best choice to be able to analyze the bar graph. So I'm going to choose a different scale. I remember that my popcorn was 6, Fruit Pops was 8, and yogurt is 5. All of my numbers, they're pretty small. They are under 10. I know that I can skip count by 2s, 3s, 4s, 5s, 6s if I wanted to. But an easy one, when I have this much space and all under 10, I'm going to try skip counting with a scale of 2 this time. Because I can easily count by 2, 2, 4, 6, 8. To make my bar graph, remember, our bottom line is always 0. Always going to be 0. And then I'm going to go 2, 4, 6, 8, and 10. So I am counting every other line here. As you can see, there's a line in between to help understand the data. So for popcorn, I see that I have 6. So I'm going to color in my popcorn all the way up from 0 to 6. For my Fruit Pops, you see that I have a total of 8 people that liked Fruit Pops the best. So I'm going to start at 0, 2, 4, 6, 8. And color that bar in. And then my last one is my yogurt. And you can see that 5 people liked yogurt. So I'm going to count up here, start at 0, 2, 4. I'm not going to go all the way up to 6. I'm only going to go up halfway to 6, which is 5. You can see here that this is right at 6 for popcorn. Fruit Pops goes up to 8. And yogurt is here halfway between 4 and 6, which is 5. So now my readers, unlike the previous scale of 5, they will be able to answer how many more people like Fruit Pops than popcorn. They can very easily determine how many people like Fruit Pops and popcorn to be able to solve this problem. So I am good at keeping my scale of 2 classmates.
So this is a much better scale because now we don't have this huge blank section up here that's not being used. We also have a scale that's very easy to read. Even though it's counting by 2s, I know that in between here are my odd numbers. So when something stops at an odd number or in the middle, I can very easily figure out, okay, it's not 4, it's not 6, 5 is in the middle of 4 and 6. So this is a much better scale, okay? So your assignment today is going to be determining appropriate scales to use with sets of data. So let's take a look at slide 5 together, please. I'll take a moment to look at your screens and make sure you are on slide 5. Slide 5 says discuss with a partner and discuss with the class. On slide 5, there are both examples that you just saw in the video. The scale counting by 5s, the scale counting by 2s. I want you to go into a breakout room with your partner and explain to them why one of the scales is better than the other. Why is one scale better than the other? Okay, you're going to explain this to your breakout room and then come back and share out. Question was, which scale helps you to analyze the graph the best? The scales that you were shown were from the video. We had a scale that counted by 5s. We had a scale that counted by 2s. Our data points were 6. Oop, I don't want to write it in yellow. Our data points were 6, 8, and 5. Okay, which scale is best and why? Question, which type of bear is best? All right, which scale is best there and why? Steve Rogers, since this is your survey that you left me out of and asked questions about, I'll let you go ahead and go ahead.
Okay, the 2's one is that makes sense. The 5 one clearly doesn't.
Can you explain to me why it is clear that it does not make sense?
Well, 5 makes sense, yes, but everything else is just random line placement, hoping that people understand and what number it is.
Steve, you are exactly right. One section does make sense. 5 makes sense because one of our data points is 5. But just because we have a 5 doesn't mean it's easy to get the others. So if we count by 5s, we are not going to say any number close to 6 and 8 on a graph. Okay? Thank you, Steve. Does someone else have another thought they would like to share about which graph is best? How about you, William? Since you didn't get enough time, I'll give you time now. How about that?
The second one's better because you can tell when it ends and it's counting by 2s. And on the first one, it's just a lot of wasted space and you can't tell where it stops. You can't tell what the number ends at.
Excellent. So William brings up a good point as well, that you can tell exactly where each one stops. Look, each one stops right on a line. Line, line, line. Now that line might be stuck in between a scale marker, and that's okay, but it's not random. Look, we just have to randomly decide a space in the middle there. That is not a good idea, okay? So counting by twos was our better choice. All right, you geniuses, now that we know which scales are best and you've had time to discuss it, we are going to switch this into a scaled pictograph, okay? We have the same data set that Steve left me out of about popcorn, fruit pops, and yogurt, okay? And we are going to take a look, Camille, Justin, and Terrence, we're gonna get your cameras back on for me, at our pictograph placement, okay? So we have popcorn, fruit pops, and yogurt. Right down here, it says duplicate the student. Miss Sousa, why are we using students? Because obviously Steve didn't ask teachers. He only asked the class, the students.
Also, some and half students.
You're right. There is a student cut in half there, and it is disturbing. I agree with you. It's very strange, but we're going to go with it. Okay. Duplicate the student to show the scale. We have agreed that our scale is going to be 2. 1 student is going to equal 2 classmates. So half of a student is going to equal 1 classmate. Poor student getting cut in half. I'm so sorry, student. Thank you for sacrificing yourself for our math. All right, popcorn. This has 6 votes. This is a group of 5 plus 1 is equal to 6. So let's count by twos until we get to 6. Come here, student. Unlock and unlock and duplicate. Go ahead, unlock, unlock, duplicate. There's 2 for popcorn. There's 4 for popcorn. There's 6 for popcorn. 2, 4, 6, 8. No, just 2, 4, 6. Okay. All right. So our popcorn has 2, 4, 6 votes on it. Let me check your screen, see how you're doing on those duplications. Elijah's got 1 student. Josh has got his students. Aiden G's got his students. And Q's got his. Oscar's working on it. Terrence, Christopher, Frank. Yours is blank. Dun, dun, dun.
Mine is blank.
You have all your duplications. I'm asking you to place them for popcorn now. So you are right. You have them duplicated. Go ahead and get your popcorn placed, which is 3 pictures because each picture equals 2, and 3 times 2 is equal to 6. All right. Fruit pops. We are counting by twos. Our total of people who voted for fruit pops is 8. So we are going to duplicate our dude and represent 8 fruit pops with 4 dudes, because that's 1 dude is 2. Oh no, I made the dude shorter. 2 dudes is 4. 3 dudes is 6. 4 dudes is 8. There's my dudes. Yes, William.
You said 8 duplicate.
Oh, sorry. I meant to equal 8. We needed 4. I was probably just excited about rhyming. 8, duplicate. I got to get my game up for when we're making songs to each other. 11, yes, sir.
You look at my screen on Fruit Pops, it looks like he has a body transformation.
It looks like what? Oh no, I muted you.
It looks like he has a body transformation on my Fruit Pops.
Oh, did he get resized? Too many fruit
Yeah,
pops. Yes, Steve Rogers.
I did something funny with the guys. Want me to show you it?
Let me see. I think I can
It
see.
still
your screen.
is doing my math, but in a what was disabled participant screen sharing.
Yes, I can see your screen over here. I'm going to take a look at it. Ah, you created a second scale and then you reversed him. Reverse.
Yes, I fixed the child.
Oh my goodness. You did, to the restored size. Okay, here we go. Now we have half of a student because this time we have yogurt and this is equal to 5. That's an odd number. So we are going to have to duplicate our dude for 2, 4. I can't add a whole nother student because that would be 6 and that's too many. So here's our half student. RIP half student. I loved you so deeply. Thank you for taking one for the team for math. All right. And we have a half there, and that's going to represent our 5. Okay. So this is how a completed pictograph to scale will look. SenQ, a question or a comment?
That's just dark how they cut this student in half.
I agree. It is. I'm gonna have to take it up with Miss Sharp. She made this assignment. I'll let her know. Terrence.
Why RP child, but we want him to be split in half.
Yes. I'm so sorry, sir. Leah.
I still remember the 6th song.
6, 12, 18, 24, 30, 6, 12. It's a good one. It's a good one. Terrence loves when I sing it. All right, slide 7, hop it over. Justin, while I love seeing your hopping juggling skills, I want to see your math skills right now, sir. All right, now we have a line plot. Okay, a line plot. We have popcorn, fruit pops, and yogurt, as we all know, because Steve left me out of it, and we're going to forgive him, even though it hurt my feelings, and I'm probably going to cry later, but I'll get over it, and it'll be okay. We are going to create a scale, okay? Now, on line plots, we are counting by ones, okay? So let's go ahead and duplicate this. Oh, hold on. You might have to move the circle to duplicate the X.
What if we take the child from off the other slide?
What if what?
Take the child from the other slide, you can copy and paste.
You could, but then it would be a pictograph. It would not be a line plot. So we're creating a different type of graph now. It's a very important distinction, Steve. Thanks for bringing that up. Okay, I can't grab the X, so I've got to move this gray circle. You probably do too. So move the gray circle, and then you can get to your X. We are going to unlock the X and duplicate it. Now, on line plots, we typically count by ones as long as the numbers are small enough. These numbers are small enough. The reason we can count by ones is because look how tiny the X's are. Okay? On our pictographs, that would be a lot of kids if I had to make 8 kids. It would be a lot of bars if I had to count up all the way up to 8 bars. But on a line plot, that X is pretty tiny, so we can represent this with a scale of 1. So on this line plot, 1X is going to equal, 1 classmate. Okay? So for popcorn, we're going to need, as our data table shows, 6 X's, okay? So let's go ahead and get those 6 X's stacked on top of each other. I want to remind you that when you make a line plot, it's very important that you keep your markers stacked up, okay? You don't want it to look like a scatter plot where the X's are just all over the place. It's hard to read if we got an X here and an X there and one up there. That doesn't make any sense, okay? So we're going to make sure that they stack on top of each other very nicely. So we need 6 for popcorn. 1, 2, 3, 4, 5, 6, okay? Fruit pops, if I use my data over here, I have 5, 6, 7, 8. So I'm going to place 8 X's, again, stacked on top of each other very nicely. so that my reader can understand the data quickly and accurately. Let me see you duplicate, duplicate. And more, and more, and more, and more, and more, and more, and more. There we go. Okay, we got 4. You probably are ahead of me because you probably didn't duplicate as slowly as me. 2, 4, 6, 8. Let me see you duplicate, duplicate, duplicate. I know, guys, I'm so talented. I understand. I understand the jealousy. I get it. What is up? Why can't I move that X? Thank you. There we go. I didn't like how those looked, so I'm moving them. Boop. 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 Okay, how many do I have for fruit pops? 1, 2, 3, 4, 5, 6, 7. Here comes 8. There we go. And then comes our yogurt frequency table. That's a group of 5. Let's move our 5. 5 to the yogurt. 5 to the yogurt. Fruit pops. Fruit pops. Everybody pop your corn. Yes, William, question?
Never mind.
Never mind. Did my craziness make you lose it? Sorry. All right, there we go. That is our line plot. Camille, your line plot is blank. That's a problem. Frank, your line plot is blank. That's a problem. I shouldn't have to say this to you every time. All right. Your independent work today is very, very similar. You are going to take a look at a frequency chart. You are going to determine what scale is best for the data. Okay, here's your data. You're going to come up with a scale. When you're thinking of a scale, you've got to do 2 things. You've got to make sure it fits on the graph. You got to make sure it matches the numbers. Okay, that it makes sense. So you're going to come up with a scale and create a bar graph with the scale, create a pictograph with the scale, create a line plot with the scale. And as always, you will review your success criteria, okay? I'm gonna give you a few moments to look at slide 9 with a breakout partner, and you are going to talk with your partner about which slide, or I apologize, which scale you think makes the most sense. So share your ideas. What number are you thinking about using as a scale, okay? Go talk with your breakout room partner about what scale you're thinking about using for your frequency chart on 9, 10, and 11. Here you go. Choose. What do you think is a good scale for this data here? What did you discuss with your partner? What are your thoughts? Terrence, what do you think is a good scale?
So what I said I was gonna do is do it in a row. So like walking 8 little freaking bars, and then I'm gonna keep repeating that step until I'm done with that slide.
Okay, so that tells you how you can collect the data in a frequency chart. The question here is, what are you going to count by? What is your scale going to be? Because we can't do 1, because look, we have 9. 1, 2, 3, 4, 5, 6. So we can't count by ones. What are we going to count by here?
We're gonna count by 2s.
2s, okay. You might count by 2s. So we'd start at 0, go to 2, 4, 6, 8, 10. My biggest number is 9, so my data would definitely fit. So I think 2 could be a good scale. More ideas, thoughts, agreements, disagreements? Okay, so it looks like we're starting to understand our scale. Excuse me. All right, kiddos, that is your independent work today. You are going to complete slides 9 through 12. I want to point out slide 12 to you. Notice that it says use the mic to describe your success with today's skill. The mic is right here. See it right there? It's pretty. You're recording your voice, explaining how you know you match the day's skill. This is not a blank slide for if you feel like it. It is a direction, and the direction is to use the mic, okay? So make sure you're following that so that I can understand your grips on speaking math vocabulary.